In this tutorial, we will be explaining how crude oil is separated into useful fractions on an industrial scale. To convert crude oil into useful products, we have to separate the mixture. In the previous tutorial, we have mentioned that there are several components of the mixture and each component will boil at different ranges of temperatures. So if we heated the mixture, we will be able to collect fractions of this mixture. Each fraction is a mixture of hydrocarbons of similar chain length and therefore they have similar properties. This process is called the fractional distillation of crude oil and it is done in a fractionating tower. So this is the fractionating tower and the whole process of separating the mixture of crude oil is called the fractional distillation. Let's study what happens in a fractionating tower. First of all, the crude oil will be heated in a furnace. So this crude oil will be heated inside the furnace. And then a mixture of liquid and vapor passes into a tower that is cooler at the top than at the bottom. So we will have here the crude oil, which will be heated inside the furnace, and then a mixture of liquid and vapor will pass through this tower, which is cooler at the top. So here we have low temperature, and at the bottom of the top we will have high temperature. So as we are going up in the tower, the temperature will decrease. Actually, the vapor pass up the tower via a series of trays. So here we have trays containing bubble caps until they arrive at a tray that is sufficiently cool. And at this tray they will condense to liquid. So for example, we have this tray over here. If the boiling point of the vapor is higher than the temperature at this tray, the vapor will condense, so it will return to the liquid phase. So the vapor will move from the gaseous phase to the liquid phase. This is condensation. So it will condense, and at each tray the liquid which condensed will be collected. The shorter chain hydrocarbons will condense in trays near to the top where the temperature will be lower. So shorter chain hydrocarbons have lower boiling point and thus they need lower temperatures to condense, and at the top of the tower we will have low temperatures. So for example, petroleum gas is collected and gasoline will be collected. Then we will start to collect naphtha, then paraffin, diesel, fuel oil, lubricating oils, and at the bottom of the tower, bitumen will be collected, whose boiling point is really high, so it is more than 350 degrees Celsius. So this is a thick residue which will be collected at the base of the tower, and it is called tar or bitumen. It is used mainly for road surfacing. However, the supply often exceeds demand, and thus this fraction will be further processed to give more valuable products. So we don't need much of this product, and thus this product will be processed further to produce more valuable products. Of course, you don't need to memorize the different fractions and their boiling temperatures. However, you must understand the principle of a fractional distillation. So again, the crude oil will be passed in a furnace to be heated up, and then it will pass in this tower. At the top of the tower, we have lower temperatures than at the bottom. So, shorter chain hydrocarbons will be condensed at the top of the tower, and longer chain hydrocarbons will condense at the bottom. These represent the trays containing bubble caps allowing the vapor to condense. So at the very top of the tower, where the temperature is the lowest, petroleum gas will condense, which is used as a fuel on site. And then gasoline and naphtha will be extracted, which are used for cars and to prepare different chemicals. As we are moving down in the tower, the temperature is becoming higher, and thus longer chains will start to condense. For example, between 180 and 220 degrees Celsius, hydrocarbon chains between 12 and 15 carbon atoms will be condensed, and these are used as kerosene and paraffin, which are used as a jet fuel and lighting. And then diesel and fuel oil will be extracted at even higher temperatures, and they are used as lorries and taxis. And then we will have lubricating oils, which condense at very high temperature between 300 and 350 degrees Celsius. The carbon chain is between 19 and 35 carbon atoms, and the residue left at the very bottom of the tower will be used for road surfacing. However, in most cases, it will be processed further to give more valuable products. One thing that you should keep in mind is that fractional distillation is a physical process, so the bonds inside the chain will not be broken. Only the van der Waals forces acting between the molecules will be broken.